looking at a use case which is based upon my previous employer, where I would work from home about 99% of the time. I would have to connect into their estate to reach private applications. So things like even the HR system or an internal technology, I would have to connect via a VPN. And when I was connected via that VPN, I would find that I would be protected on my web side of things. Policies would be applied, certain websites would be blocked, etc. But only when I was on that VPN. The minute I dropped that VPN, I could go wherever I want on the internet. And that's because my traffic couldn't go through the security devices that they had sitting at the network edge. So it was only when I was on the VPN that would happen. And that is called hairpinning, where I'm connecting into the company to go back out of the company. Now that caused me issues on a daily basis because I would have clients that I would have to connect to that would not work if I was on that VPN. So I would sometimes spend my entire day connecting, disconnecting from either the client or my company in order to do my job, in order that I got that connectivity to the company side of things. It became a bit of a nightmare for me. And again, the company isn't protecting my machine when I'm not on that VPN either, because of that limitation by where my traffic had to go. We also have bring your own device, where we've got users that could be connecting to that network from their own machine. So a use case that I had was that I once went abroad, so I went on holiday. I logged off my laptop that day at about 4 p.m. I went straight to the airport, waited a number of hours on a flight, flew out to the Middle East. And when I was in the Middle East, I realized I had not turned on my out of office. So I took my brother's laptop, I logged into Office 365, and I enabled the out of office on my email. So when you look at that, you have me as a user now logging in from a completely unknown machine, logging in to a cloud application, and I'm coming in from a completely different country, but there was no alert, there was no block, there was nothing to really control me doing that. And we look at, we have to have agents on devices, and we can't have agents on maybe a user's own machine, etc. That's another limitation of the legacy way of handling web traffic. Now we have cloud apps, we have infrastructure as a service, we've got applications hosted in the private cloud, etc. And the same principle applies of how are we going to protect these resources from nefarious individuals and malicious use, and also control what can be done by our own employees accessing these things. So we're looking to control access, control activities, and make sure that no nefarious individuals are logging into these assets. So in the previous workshop, we focused on the next generation secure web gateway from Netskope, which is the CASB or Cloud Inline, which is where we're controlling those activities. For example, we go on to WeTransfer. We don't want our users uploading to WeTransfer. There's legal ramifications of that, loss of control of the data and so on. We look at the secure web gateway side of things, controlling what websites and applications that users can visit. And then we've got the DLP side of things and the threat protection as well under that, which is protecting what users can upload, what they can download, doing checks on a particular type of files. And then we're going to go a little deeper today. So I'm just going to jump over to my remote session. And we'll start by discussing onboarding. So common question that comes up, how easy is it to roll out? Well, there's a number of ways that you can do this. I'm just going to jump in. I will say, first of all, I cannot be full screen in this RDP while sharing in this GoToWebinar. So you may see some strange behavior from my mouse, just ignore it. If I jump over to our backend settings here and into users, the first way that you could do it is you could manually add a user. And all Netskope needs to have a user added is it needs an email address. It's driven by email address for the username. The email address can be accompanied by a first name and surname when you're using the manual process, where we can upload a CSV file full of email addresses, first names and surnames, or we could individually add them here manually. Now, when you add a user manually, you can send them an email invite that allows them to download the client directly from the tenant. When you download that client, it will come with a file name that contains a big string in it with all the information needed, that when that client is installed, it tells the tenant who the user is and it registers that client to that individual user. Now that's important because that's called single user mode. Single user mode is where anyone, if I was to download this client right now via this process on this machine, it is cemented against the user invite link that I used for it. It is badged against me, for example, and anyone that logs into this machine, the client will load, but it will always show up as me and the tenant as the person that is using the web on this machine, regardless of who the user is. So if you have users out there that have individual laptops and no one is going to log into them except for that user, then single mode would work. But if you have any machines where it can be multiple people logging in, we have to do it a little differently. But this is the easiest way to roll it out. You just upload a CSV, get that email invite sent. They will need full admin though on their machine to install the client. So that's a little limitation there. You might not want to give your users full admin, but that's when we look at the alternate methods to get it rolled out. If we now look at Active Directory, so we want our users to be managed from here, from a central location internally, and it's from our domain. So I've got a couple of users here. We've got Netskope demo. We also have a Netskope group. If we return to our tenant, we can see that Netskope demo is here. And you'll notice that I cannot delete the user because they have been imported. Now, we have a cloud tenant. We have an on-site Active Directory domain. So how do we bridge the two and get our users from Active Directory into our cloud tenant? Well, we use this simple little tool called the Directory Importer. Now, you can run this from anywhere. It is a service. So we have a service, a Windows service here. So you can run this from any modern Windows machine as long as you have the Visual Basic C++ 2010 redistributable installed on that machine. And you could have your users, if we look at the service at the moment, go back to the service, we have a service account in here, but that could be an individual user. As long as that user, the user using this particular machine, has the power to query the domain, it can be their account in here. This will periodically go to whichever settings you have configured here. So you can see that I've got the Netskope demo group is actually set up to be queried by this importer. It's not querying the entire domain. It's not using a generic bind account unless you configure it that way. It's checking every 60 minutes on this machine. The default is 180 minutes. Can't go any lower than 60 minutes. And I can alter some categories of AD based on how my AD is set up as to what fields to pull. Now that's important. Maybe you don't have the user's email address, their correct email address in the email field in AD. You're using it in a different configuration. So you can overwrite that and say, check this field instead for a particular attribute. But all we're doing is we're pointing at this AD group and we have a user in this AD group. So every 60 minutes, it will now poll that AD group, take that information on the users that exist in it. It will send that information up to the tenant, and the tenant will now transfer those users into a Netskope user inside of the tenant. I will add one. There's no way for me to speed it up, but we might see them appear by the end of this call. As I say, it's every 60 minutes it's going to check this. I can restart the service and so on, but it makes no difference. It's got an internal clock set to 60 minutes, so I cannot force it any faster than that. So our user's now added, but we need to get the client onto the machine. We don't want to give the user admin rights. We want to push it out from a central source. So we could use something like group policy now to install that client on the machine, or we could use some kind of automated push out, like using SCCM or something like that. If I come to my desktop, I do have a couple of examples of this. If we look at our install script here, now you are going to see some tokens and keys and so on for our test tenant. There's no way around that for me, but I will be resetting them all at the end of this webinar. So here is an example of the install script for AD. I've got the installer, so I've got the client, I've downloaded that, I've got that in a central repository. I have my token from my tenant, I've got the address of my tenant and so on that it needs. But the important thing here is the per user config mode. That I can also store the user's settings and so on wherever I want to on the machine. And I've enabled auto update here, which means that rather than have to do rollouts of software and so on, where you're having to patch all your systems, the client can keep itself up to date inside of the tenant based on your settings, so you don't need to do patching and so on of this. But the per user config mode is important because what it's going to do if I enable this is it's going to pick up the user details from how they're authenticated on the machine. So we have behind the scenes on an AD account, we have a first name, surname, we have a email address, and we also have a UPN. So think of their name@domain.com as their username really, and it's also their email address. So as long as we have that information, it will read on a Windows machine when the user's logged in who they are and will match them up to a user inside of the tenant. So I've just got a little bat file here that will install the tenant for me. You can see in the background that it's just running that exact same command that we did. I'm not changing the user location for the settings is the only difference. So this will only take a couple of seconds. And that's it done. So that can be run silently behind the scenes. Users don't even know it's happening. And you can see in the bottom right-hand side, I have a client. It goes blue or colored, meaning that it's now connected. And if I go into the configuration of it, you can see that it is badged to the Netskope demo at netscope.com account. Now, I also added Netskope demo 2 to that group. So once that user appears inside of the tenant, if that user logged on to this machine, the client will now read who that user is, and that username here will change. It will change to Netskope demo 2, which means it doesn't matter who logs into this machine, as long as they've been onboarded via AD, as long as that information is in the tenant, Netskope will pick up who they are and will amend their user details here. Now, because we're using the directory importer as well, if we jump over to here, the group appears inside of the tenant as well, which is important because now we can, we can change our policies to match groups. So rather than have it set, I've got this policy, for example, set to individual users. I've got this policy set to groups. So not only can we easily onboard our users, easily roll out that tenant, we can now configure our policies based on team. So we might have a marketing team, a sales team, a tech team that need different rules when they're connected via the Netskope tenant. A particular use case for that is people always block gambling in their categories when it comes to not allowing web access, but there are some companies and teams that would need access to gambling sites. So say, for example, a gambling company is one of your customers where you're rolling out a solution for them and you have to access their resources, but they're all behind a gambling domain. Then you can either whitelist that for everyone, or you could whitelist it based on group for who needs to actually access that client. So that is the AD side of things, how to easily roll it out, but we're going to do it a little differently now, and we're going to use Okta for that user onboarding and the verification of who the user is on the machine. Before I do so, I will just get rid of my client. So while that's going, let's take a look at our Okta. So here in Okta, we have applications. Now these applications are available in the Okta marketplace. They are easy to configure. Netskope are very good at giving you step-by-step instructions, not only for the Netskope tenant, but also the Okta side of things, both inside of Okta and in the Netskope tenant within their help section. I have configured this SCIM for user provisioning, where we're going to take users from Okta and we're going to push them over to the tenant. If I go into it, we can see that we have one user in there at the moment. I can add another user, which is this Netskope demonstration 2. Before I do, I will quickly jump back and show we already have Netskope demonstration at gmail.com exists inside of the tenant. Here, I'm just going to assign another user to this application inside of Okta. And there we go. So that's an individual has now been added to this particular tenant. Now I could have added them to the group, or I can add them individually, but Netskope should now be pushing out that information to the tenant. If it doesn't work, I'll add them to the group and we'll see, because I might have it only configured for group. But eventually this user, in the next couple of minutes, should appear here as a new user. In fact, there we are instantly. We now have Netskope demonstration 2 has been added to our tenant by Okta. So we don't need that on-premise anymore. We're using a cloud-based IAM Okta instance. We could manage our entire tenant. I have the group assigned to this Okta application called demo-Netskope. So it's Netskope, not Scoop. So now we can again do that policy, group-based policies inside of the tenant, but we're using the groups in Okta. So we don't need any on-premise interaction at all here. For managing our users, it's all coming from Okta. If I jump back, I do have another application here, which is the SAML application. Now, these are separated in the Netskope guide that you have to have the two applications set up, but our Okta wizard did it and only had one application enabled, and it still worked as long as you've got the correct information in it. But I've done it separately the way that it's told by the Netskope guides. So the SAML is going to handle authentication as well for us. So the SCIM or SCIM is doing the user provisioning, but the SAML is now going to allow us to authenticate and identify our users for an actual client. If I now come back to my installation scripts, see here that I've got the same type of rollout. So again, you could push this out to machines from Active Directory or any source, but you don't actually need it for Mac. Mac automatically sets it into an enrollment way. In Windows, this is handling that. So rather than us need all that information from the tenant, such as the user information, the license and so on, that was going to be in the big file name if we sent the invite, we can just set this to IDP mode, which means that when the client first loads, it's going to ask the user to authenticate who they are, and it's going to check whichever source you've got. We've got Okta configured here for that user, and it's going to allow the client to be badged to them. So I'll just do a quick install, just make sure my client is gone on this. Again, just very quick rollout. You can see in the background here, I've got an Enroll Netskope client window. It's connecting to Okta. So let's put in our Okta information for one of our users. Enrolled successfully. I can close this window. Give that a moment. It's now registering the client. And we now have it set to Netskope demonstration at gmail.com. So this client is now ready to use. I could try and access something I know is blocked. We'll use the gambling example. I will go to a random gambling site, and there we go. We've got full protection on this device now based on our policies. Again, individual user or groups can be assigned to that policy, and that's how easy it is to roll out. You just push that client out to the machines, the user authenticates, and away you go. That's them now protected. And they don't have to be on site for it. It's that easy to roll this thing out. I'm going to just quickly get rid of this IDP client because one of the future demonstrations I'm going to do needs the Windows one. So let me just refresh this. Get rid of this. And we'll pop the Windows one back in the AD side of things. Well, that's doing that. Let's quickly jump back. So I've got the two applications here. I've got the SAML, and I've got the Skim. They're both the same application. It's called user enrollment when you're in the marketplace. I can do a quick add application here and show you how easy it would be to integrate that into your Okta. If I do a quick search for Netskope, it was this Netskope user enrollment one, but I've added it twice, one for Skim, one for SAML. We can also do the admin console. So when I'm logging into the actual tenant itself, I could be handling all of that via Okta, enforcing MFA, centralized user management, etc. Could all be coming from Okta too. So not only is your tenant protected, but your end user devices are protected and all coming from that single source of truth. We have the other one here, reverse proxy, which we're about to go through. But these are the applications. Very quickly, you can just click on one, add it to your Okta, go to the Netskope tenant. It will give you step-by-step guides on how to configure it, what settings to take from your tenant. Even in Okta, once that application's added, there is an option to view those instructions end to end as well. And you can't really go wrong with it when you do it because it's so straightforward. You're just copying a field from one place to another. You can't really go wrong with it. It's that simple to do. So I'm just going to jump back to our client, make sure that is gone. That is gone. And I'm just going to put the ED one back in. So this will just be a moment. So we're going to discuss reverse proxy now. So the use case for this, I am a user. I am using my own machine. So think back to my use case earlier. I am someone who is sitting at home. I've got a personal laptop. I want to log on to a personal company resource from my personal laptop. I do not have the client installed on my personal machine. I'm not going to install the client on my personal machine, but I'm going to log in to this resource. I have the client running at the moment. So that is badged to me as the Netskope demo at netscope.com user. And I'm just going to log into Salesforce here. So here I'm using single sign-on to get into Salesforce. It's coming from the Netskope demonstration at Gmail account. And you can see that I'm straight into Salesforce. I am now logged into this. I can try and upload something that is not allowed. So let's go to Salesforce Chatter and Chatter. And I'm going to try and upload some GDPR information to this, and I'm not allowed to. You can flip that on its head and have it that I'm not able to download it. You can see that because I've got the client running, it's not allowing me to upload this particular file because the advanced DLP of Netskope has identified that this is an identity card. I have a fingerprint in place for this to say if there's any personal information that is going to be uploaded to this site. I have it configured for download as well, but we have to get the information into there first for me to download, but I'm not allowed to. So that image has been read by the advanced DLP. Netskope has identified that it is an ID card. It is seen that it's personal identifiable information. And as per my GDPR policy, it is blocking me from doing that upload. And I'm getting a warning here from the client telling me you're not allowed to do this. I can put in a reason and so on. I haven't allowed the user to get past this. We can only back out. So I'll stop that. And unblock. Due to corporate policy, it is not allowing the upload. So that's me on a machine that has the client installed though. What about the reverse of that where I don't have the client? I'm going to close my entire browser here just so that we reset all the authentication and so on. And I'm going to turn off my client. So I'll just disable this. Make sure that goes gray. So we no longer have that client running. If I can get back to my desktop without clicking notifications, no, I can't. I need to scroll over. I will go back in. So I'm going to log into my Okta first, just to give me that single sign-on again. There we go. And now let's go back to Salesforce. I get my option again. Now the question is, what is different here? What is actually different? It doesn't look different. To a user, It looks completely transparent. They're not seeing anything that is any different. If I now try to do the exact same thing with my chatter, we will try and upload a identity card again. And you can see it's blocked by corporate policy. Now, I don't get a warning this time because I have no client running, but the policy is still being applied. And the way that's being applied is, if you look at the address here, we now have a Netskope reverse proxy URL embedded into our overall URL here, which means we are actually still going via the tenant. So this is configured for anyone logging into particular applications via particular identity providers, Okta being one of them, to enforce policy even though you do not have that client installed. So when you think back to the example at the start of the call, we had me in the Middle East logging into Office 365. I could have done whatever I wanted. I could have downloaded emails, I could have downloaded files, I could have been anyone because I was coming from an unknown machine, I was coming from an unknown country. Well, this way, even if someone got into here from a machine that did not have a client installed, you're still getting that protection because you're logging in with your Okta credentials. Okta is handling the authentication and the user management and so on, but it's then handing the traffic over to the Netskope tenant. The Netskope tenant is now presenting this information back to the user, but because that traffic is going via that tenant, any policy created for this particular application or activity is now captured, even though I do not have the client installed. If we quickly log into our tenant again, give me a moment. So here at this screen, when I showed you the application for the admin console, I don't have it enabled here because this is my own personal developer Okta account. We are in the process of moving to a new test lab inside the Somerford. So when that happens, we will be implementing that, but for now it's not. But I could be handling this user authentication via Okta as well to get into the tenant, rather than having this front door of the tenant sitting unprotected. That could be protected by Okta as well. Give you that centralized management, MFA, single sign-on, all of those goodies that an IAM tool like Okta gives you could be put on the front door of your tenant as well. So I'm just going back into the tenant. And if we come to our policies, full-time protection, you can see I have a Salesforce policy here that is blocking the GDPR image profile that I'm trying to upload. And that is being enforced, even, I can't stress it enough, even though the client is not installed, it is being captured because the traffic is now going via the tenant. Now, there is another side of this that I cannot show you on this because I only have one machine and it causes issues if I try to run both at the same time. But we can do a thing called enforcement as well, which is a stricter rule than reverse proxy. If we come into our security cloud platform, and if I can get my Mac to scroll down on this while I'm in the RDP, and we have enforcement. You can see that if you've got one of these identity providers here, so we're using Okta, enforcement is, rather than allow the user to log in and go via the reverse proxy and so on, the user will be asked to download and install a client before they can access a particular application or website, if you've got it configured inside of your tenant. So if I was to uninstall the client, try and run that Salesforce, and this was enabled, I would now be taken to a page that asks me to download the client and install it before I can access the resource. So you have those options. You can either put on the reverse proxy, which forces the user via the tenant, even if a client is not installed, they can still browse and so on. Or you could put on enforcement, which would force them to actually download and install a client for that to to function for them. And it's all about protecting those front doors. Those, you think of it, you had a application on your company resources. The only way someone could get to those, you've got firewalls on your network edge, you need to be on a VPN. You would have to be classed as low trust, going in via VPN to come into a high trust area in order that you can actually access these resources going via that VPN and so on. But now you've got all these front doors sitting, like the Office 365 portal, like the Salesforce portal that we looked at, and they're all sitting outside of your company. So how are you going to protect those front doors? How are you going to enforce these policies? By using a client like this on the end user's machine, or using the reverse proxy that will allow you that control. So there is another side of this that we can show as well. I'll just quickly make sure my client is all working. We'll just pop this client back on. Just check if my Netskope Demo 2 has appeared. I have a spelling mistake in their name, but yes, they appear. So I've got Netskope Demo 2 has now been populated by the AD importer. And if I didn't have that error in the name, I could log into this machine using Netskope Demo 2, and the client would now show them in the configuration as the number 2 user. So in here, that would change to Netskope Demo 2 because it's picking it up from their UPN when they're logged into the machine, which means that as per that per user config, anyone can log on to this device as long as they're a Netskope user, they've been onboarded from AD, these details can be checked by the client, and that traffic would now show up inside your tenant badged to that individual user, as opposed to it always being badged to a single user, which is what's going to happen if you use the rollout using the email invite, the single user mode. So we're now going to take a look at, on the subject of the private applications, let's do a quick RDP. So I'm just going to connect to a device. This is my domain controller. Now, sometimes when I do an RDP within an RDP, it doesn't show up, but we don't really need it to. You should see local session manager. It may be quite slow. It's quite a small Azure instance that I'm using here. I've just RDP'd onto a machine. Does it look any different? No. Does the user notice anything different? No. It just looks like a standard RDP session from one machine to another. But what to think of is, now we'll have to pretend here, I'm going to sign out of this, pretend that this machine where I launched, if it's going to actually end that, as I say, it's a slow RDP, I'll just minimize it. Pretend that this machine that I'm on at the moment is completely outside of the company. So I'm a home worker, I'm stuck at home due to COVID, but I still need to access those internal resources. So an internal application or RDP to a device that's on premise or infrastructure as a service in a cloud instance. How am I going to do that? Going back to the original model that I showed, we're going to use a VPN. I'm going to have to launch a VPN, be trusted on the corporate network, and now I can RDP to whichever device I need to access. But we can handle that via Netskope, and that is the private access side of things. Now, I wouldn't call it a VPN because it's not got that same user feel where you have to launch it, authenticate and so on, get the connection and then open up your RDP file and so on. It's handling it via the client and it's always on. So the user can launch that RDP from their home and be taken to the internal resource as long as that client is there and running and they're allowed to. Now, the way that works is I have a publisher in my on-premise estate. That publisher is talking to my tenant. So when I launched that RDP file earlier, the client recognized, steered that traffic up to the tenant. The tenant now sent me to the publisher. The publisher connected me to the target device. I did not launch a VPN. I did not connect to any other third-party software to get that trust. It was handled by the client, going to the tenant, publisher, target device. And I can only access that one device. If I quickly jump over to my policies, if I can scroll up, you can see that I have an NPA RDP policy here. This particular group can launch it. In fact, we've got users and this group. So the Gmail user coming from Okta can do that RDP. And the Netskope group from AD, anyone in that group can do this. It's called a private app. So that is deemed as an internal application or internal resource such as RDP, SSH to a Unix device, etc. I define the application in my settings. I can, again, Mac to RDP. Can't scroll up. In here in my private apps, I have it defined that it is only this address that the publisher is allowed to handle that connection to. So if I tried an RDP to 10.0.0.5, I am not allowed. If I tried on any other port, I am not allowed. But it is handling the RDP side of things to that internal device without me needing that VPN. And it's key here that I can only go to a single IP, because the number of clients that I have worked with, they will give me a VPN. I will authenticate into that VPN, and once I'm in, I can essentially go anywhere. And with some clients, they will give me a domain account that is put into a group for some tech group, which means that I can access and wander their network as long as that account works. But if I was given a local account on this machine instead of a domain account, I can only get to that machine through the client. And because it's a local account or a domain account that would be locked down in some way, that or added individually to this device in the admin group or whatever, I can't wander the network anymore. As I say, it's always on. So your users sitting at home can launch this. They can go straight to the internal application via that RDP, for example, but they can still access all their web resources and have that protection from the client as well. That's still running. So it's almost as if they're on-premise now, reaching on-premise resources, but still being protected, even though they're at home. The machine is protected, the web traffic is protected. They've got that complete bubble around themselves, but they don't need a third-party tool to get to this device. They don't need a third-party VPN. So when it comes to the costing of this, when you're looking at the Netskope solution as a whole, you could be getting rid of your old secure web gateway, so whatever that's costing you to run and maintain, particularly on-premise ones that are sitting in racks and data centers and so on. But you could also be getting rid of any licenses for a third-party VPN if you were to configure the private access. You have to purchase private access and have that configured. But I find it more secure because of the way that it works based on policy, individual users, individual targets that I'm going to, specified ports and so on. The control of this and the ease of use for the user is a really, really good function. So we're just going to take a look now at the Cloud Security Posture module. So I don't have a lot of cloud resources. I'm using all my own personal for this while our test lab is being rolled out, which is imminent. So we're just going to walk through this. I'm not going to configure anything or do any use cases like uploading malware to a cloud bucket, but we'll talk through the principle of it. So Cloud Security Posture module, what is it? Think of me. So I have went online, I have registered for Azure, I have registered for AWS, I have registered for Google Cloud. They all give you free functionality. You could do this right now. You could go and spin up a couple of VMs in Azure, AWS, Google Cloud. You could do it straight away, fire up some machines, go through a couple of wizards, really intuitive interfaces. You're picking your OS, you're picking your size, picking your tier. You've created a VM in the cloud. We can take that information and we can put it straight into a tenant, and it will now start giving us a security assessment of how good our cloud setup is. So if I come back out with this and into app enabled protection and cloud infrastructure, you can see here that we've got AWS, we've got Azure, and we've got Google Cloud. All I've done is I've taken the step-by-step guide, really intuitive, really straightforward guides inside of the tenant. When I click the setup option here, it tells me everything that it needs, and it gives me instructions and so on, and how to complete each of the steps. Everything really user-friendly in this tenant. I add some information, I enable a couple of things depending on the tenant, the cloud instance, like for example, a certain permission or a certain Azure AD app that it might need in order to do this. And it's now going to perform certain checks against my cloud estate. So you can see here for the AWS one, we can do DLP, we can do threat protection, and we have the continuous security assessment. For Azure, we've got all three as well. I just don't have them turned on for the Azure one. I've got the security assessment turned on for that. And for the Google Cloud, we have the security assessment. No DLP, no threat protection, but we've got the security assessment. In the front end of our tenant, if I come back to it, we have the security assessment option here. So this is us in policies. This is where I can configure certain checks to be run against these cloud instances. So now that we have them enabled in the back end, we've got green ticks that it can access the resources inside of our cloud. We can now roll out policies to perform checks against those cloud instances. If we quickly jump into profiles and roles out of the box, it comes with tons of these rules. There are things like, if we click on this one, I'm no cloud expert, but even I can read these as to what it's going to look for when you look at the out of the box ones. We've got a definition here. It's going to be looking for, has this extension been applied to a VM? How do you remediate it? What steps would you take inside of this cloud instance to fix this issue? So they're giving you a way of checking for what the problem is, but they're also giving you the solution in a step-by-step method as to how to fix that particular issue. And then we've got each of the standards. So we can see here we've got NIST 800, which particular policy, which control does this relate to? So if you had to adhere to some kind of standard like NIST, particularly important in defence and so on, where you've got a whole list of, maybe you've taken all of your various MOD defence policies and compliance, and you've whittled them down to a particular key NIST list, which will tick them all off. You've got maybe about 100 compliance controls you now have to adhere to. Well, this will actually go through and it will check them for you as to which control you're actually fixing here when it comes to applying one of these rules. We can then set these as a policy. So we could customize all of those rules. We could create our own benchmark using the out-of-the-box ones, or we could create a brand new rule from scratch if one isn't covered, or we want to tweak it slightly to include something else that merge two rules together or something like that. And we would just pick which cloud platform it is, which profile, which compliance we want to look at, which rules we want to check, and we save that policy. Enable it. It's now going to perform checks for us against our cloud estate. If I now come back to our cloud infrastructure here, we get a full overview of what the tenant can see in each of these instances. So you can see here it just matches what we saw in the back-end configuration. I had 2 AWS accounts, 1 Azure, 1 Google Cloud. I can click, I can view usage for these. It can give you an idea of the billing side of things. The billing side of things when it comes to cloud estates is still a mystery to me. I build a VM, it says it's going to cost me 4 pence an hour, and then I get hit with a bill every month for like 30 quid, even though it's been off. So this will give you some kind of idea of the billing as well when you look at the usage. I can view the overall details. So this is an inventory we've now flicked to on the left here, where it shows me exactly what instances we've got in each of these providers. So I don't have much. So I've only got a couple of VMs set up in Azure, nothing really in AWS, nothing really in Google Cloud, but it's still telling me what resources I am using in each of these cloud estates. Very good for inventory of your cloud. If people have got the rights to go in and do what they want in cloud, then you can get a grip on that. And you can see exactly what's been built, what's out there, as long as it's under that account that you've allowed the tenant to look at. And we also have a breakdown over the compliance rules that are being breached here. Now, this is important for me because with me not being an out-and-out cloud expert when it comes to spinning up VMs and configuring security groups and so on for AWS, for example, I use the wizards. So when I'm creating a VM, I go in, I just pick my size, I hit next, next, next. I get a couple of warnings about maybe a port being open, but I hit next, next, next. I hit create, and then I've got my VM. But behind the scenes of that, I'm sure a cloud expert can sit down and look at it and go, this is you've got Swiss cheese going on in your firewall, anyone could be attacking your device, etc. And it's just because the wizards are built for convenience, they're not built for security. They do give you some warnings when you're creating a VM. Some people also rush into cloud, where, especially during COVID, there was a whole push for, oh, we need to move to cloud quicker because companies get caught out with the users having to work from home and couldn't get back to resources on premise that had to be closed and so on. That rush to roll out can catch people out as well, in the same way it catches me out if I spin up a VM and use next, next, next. This gives you an idea of things you may have missed when it comes to the overall security of your cloud estate, things that you might not even have considered, you might see in here. Very simple ones for me are, if I try to create a Windows box and it asks me, what do I want the local admin to be? If I try and type administrator, Azure will instantly say, no, you can't use that anymore. So I use local admin. And I guarantee that there are hundreds of other people out there every day using local admin instead of administrator for their main local admin account that's created when that VM is spun up. The same applies to Unix boxes. The on-premise mentality creeps over to cloud. So when you create a Unix box in cloud, they want you to use keys. So they will ask you to generate a private key and so on for accessing that device, and you'll have to use that if you want to SSH onto it. Or you can override that and you can set it to a password, but you'll get a big warning for that saying don't use passwords. You'll also have root is disabled automatically for logon when you spin up a VM. But once you've got access to the box, you could re-enable that and have root allowed to log in. And these types of things creep over from the legacy way of working on an on-premise estate, where for convenience a security team might have allowed root to log on to a particular box. Things like that, this will catch them. So all of the rules and so on for particular devices, it will go in and query them. If we look at our compliance now, when we looked at the rules previously, this is showing me all of the rules that I'm breaching right now from the estates that I've got configured. And you can see that I'm failing on 39 of them. And all I've done is hit next, next, next when I've been building the VMs. Just using the straightforward wizards in each of these cloud instances, I am breaching all manner of compliance and so on. Now we can go a step further than that. This is just looking at the overall security of the estate. So this is the continuous security assessment, or the security assessment option when we were looking at each of the cloud instances that had been onboarded. But we also had the option for DLP and malware. So usually with your client, we saw with the Salesforce that it blocked me uploading the GDPR information to the Salesforce set, and it stopped me downloading if I managed to get it up there, if it wasn't blocked, then I could have tried to download it and it would be blocked as well, to stop that proliferation of data that may be sensitive from users. With our API-enabled protection inside the Netskope, we can configure that to look at data at rest in particular cloud applications. So I've got it set up here for Box. It will go on to Box and it will check to see if there's any files in storage accounts and so on for users that breach any kind of DLP rule or malware. But we can also roll that out to our cloud as well. So inside of this estate, we will have things like, data buckets inside of Amazon. we've got users uploading things to those data buckets. They're storing files, they're accessing files, downloading files, etc. If that was on premise, how would we protect that? We would probably have something, an agent installed on our company machines, like a McAfee or something, a McAfee antivirus or something like that would have to go onto all of our servers. And anybody uploads a file to it, McAfee agent's now going to kick in, it's going to scan that file, check it, read back from the EPO database for any threat or DLP policy and so on. But how are we going to do that in cloud? Because in cloud, we've got infrastructure as a service, where I can spin up a server and I can install an agent onto that, an antivirus agent. But if I've just got a data bucket, I might not be able to install an agent onto that. But this can go in and can actually check those particular buckets and can do DLP checking, can do malware checking. If I come back a screen and we go into our constraints here, you see that I get a storage option here. So I don't have any configured, but I could call this like AWS DLP scan. There is my account. So remember, we didn't have it enabled for Azure. So I know that that's AWS that it is enabled for. We have that account. And we have a bucket in there. I can select by bucket, so it doesn't have to be all of them. This is a data bucket that I've got in AWS. So if I was to enable this constraint here, and then we went into our policies, and created a policy for it, we could now be, you can see that this policy here has been set up by a colleague of mine for their AWS instance. They're doing a check for PCI information. They're also running security assessments against that estate. So they're checking for DLP with this, and then they're running various security assessment rules against their AWS estate. So you're getting that overall view of your compliance. You're getting to see all these failed rules and so on. But under the surface, you're also getting to see the DLP, any malware that's been uploaded. You're getting that protection at the file level, at the data at rest level inside of those buckets. And the last thing to round us off, because we're coming close to time, is everything we've done today. I'm just going to quickly go into our network events. So you can see that I now have the ability to see who connected to that particular device over the RDP, because Netskope handled that connection. So when I was RDPing onto client devices with my previous employer, for example, they would probably have no record that I ever logged onto that machine. There would be maybe a timestamp somewhere for me going onto the VPN. There would be a timestamp in the Windows device where I would be logging on, but they probably weren't monitoring. They probably never had Splunk enabled or anything like that would pull that information and show exactly who's accessing their estate. Well, Netskope can now tell you. So you can see here that I RDP'd onto that machine 20 minutes ago. I can see exactly who I was, coming from my client information, so it was me. I can see the machine I came from, I can see how I connected to it with RDP, etc. And I can't scroll down on this, let me just move my mouse over. And we got all this information about how much, what was I uploading, what was I downloading, what was I, it's not recording every activity I do on this machine like a PAM tool would, but you're getting that visibility over who's connecting to your devices via the private access. And in our application events, we can also see that I was trying to do stuff via Salesforce. Even though I didn't have the client installed, I now have the visibility of activities inside that application because I was going via the reverse proxy. So not only was it enforcing my overall policy when I was in that tool without the client running, I'm getting the full visibility of what the user was up to as well. So it's kind of a nice little package there of how to protect your devices, both in the cloud and off-premise machines, even those that don't have the laptops with clients installed with the reverse proxy. We looked at the Okta integration there. So we relied on the Okta integration for the SCIM that was pushing out the users from our provisioning application in Okta. So we can now centralize all our user management for this Netskope tool. We could then have the user authenticate themselves with the client, have that rolled out quite easily. They just input their details as soon as it's installed, as long as it's in per user mode on Windows, but on Mac, that's by default. If you install the client on a Mac, you'll be asked to enroll if there's no user information presented at the time of install. We showed how to pull your users over from Active Directory. If I jump back to my settings here, and in using both of these options, for the Okta side of things, we get to pull over groups as well. From the AD side of things, we get to pull over groups. If we use the single user mode, so if I was to just create a user here manually, I cannot apply them to groups. They can only be single user. They can be applied to a policy as a user. I cannot add them to a group and then have them managed as a group. But using the directory importer, using the Okta provisioning, I can now use groups. I can create all my policies based on group or team you belong to, etc. And we had the reverse proxy app in there as well, very easy to set up. And that is really it. So I'm just going to jump back to my presentation. If I can get my window back up. So here at Somerford, we use Netskope. So if I could show you my Mac at the moment, I have Netskope installed. We're rolling it out. I've been doing all the testing and so on, creating policies. We use Okta. We believe in these technologies. They are the best of breed in their particular sectors. They are absolutely fantastic tools. Fully qualified engineers. I myself have just been invited to Netskope Prime, which is an invite-only technical side of things for Netskope when you're an engineer. I've done all the courses, so we're well versed in what we do. We have support desks on site that can assist with any issues when it comes to rolling out these products and general support of them. We have complimentary workshops like this where we can take you through the tool. Doesn't matter who attends. We don't ring fence off for sharing of our knowledge on particular solutions. And it's when it comes to our technology portfolio, when we focus on things like Okta, Splunk, Netskope, we're looking at the integration of these tools, how they work well together to form a cohesive security architecture that covers your entire estate, not just selling you anything to get licenses. Previous employers that I've worked for would sell competitors. They would sell like 5 different PAM tools and would always have one ready to go to a client. Well, we tend to use practice what we preach, and we only tend to focus on one particular tool and give it our complete attention.